Good morning, students. Today we continue lecture part of Medical Informatics and Biostatistics course as part of combined Medical Physics with Medical Informatics course. And let's move into lecture 4. First lecture for this course, and I will try to provide for you some introduction about basic statistical data analysis, which is applicable for medical area, also introduction biostatistics method as background for evidence-based medicine. Probably we will have too much question for a single lecture, and it will lasted for maybe even 2 lectures, I think. So, in general, we have arranged the following agenda, which have included 4 major questions about usage. First of all, it's like brief introduction and recap about technical solution we need, software solution we could use. It's, for example, spreadsheet application, how it's possible to conduct some mathematical calculation and in general calculation with this application. Then we will concentrate on statistical calculation, hypothesis testing, have to consider correlation regressional analysis and optimal management task solving. So let's proceed with first question, which is actually, I will follow very quickly because it's kind of requirements for course, and actually it's very fine explained in various online resources. There is plenty of it, so I just point few moments, few questions which is essential for your practice works. So first of all, if we've spoken about calculation, we have to admit that it's actually major aim of spreadsheet application, it's to do calculation. So major reason of its existence. And what we can do from simple calculation like above, when we utilize our data from worksheet for simple arithmetical operation, and we could create a relatively complex statement like below, with combination of various arithmetical operation function, which include arguments composed by range or individual variables, and so on. And here is actually, so first of all, I think it's obvious that's general structure of equation. It's like started by equal characters. That after that it has to be followed by any valid mathematical or arithmetical operation, and just variables we usually replace with reference to those cells which contains our data. What is important to admit that on the specific location, Excel function could be localized and translated into local languages. So here, as we have, you can see exactly this situation when some function remain in English like ABs, but SQRT translated into Russian in this case. So it's have to be aware. Like for me, not bad, not a good practice, but it's can be seen, happened, and faced, and you have to be ready for this. If we will consider the formula anatomy more detailed, that's any formula starts from equal signs that could be composed multiply function or arithmetical operators. So function give us chance to make specific calculation at once, and its syntaxes consist of function name and arguments provided within brackets. Function could be separated with multiply arguments, and each one arguments could represent like a range or single reference. And depending again to location settings, usually range delimiter is colon, whereas arguments delimiter could be comma or sometimes semicolon, depending to local settings. Okay. And one more kind of example about specific kind of Excel function, Excel formula you have to use. Let's see, you will be like ordered it within one of the class. It's array formula. So actually it's built on top of conventional formulas. Most of function could be used as array if function allowed to provide arguments as range, it could be used as array formula. So means that all array values will be processed with given formula or function. So in this particular case, we have like each one array range will be multiplied by specific array constant according to index of array. So, and curly brackets exactly denote what has to be done, like array formula at all, and array constant or array arguments, if it could be even another function, has to be provided. Or what could be arguments of formulas as well as function. For sure, it could be constants like text, numerical data, if it's like appear only once or used this value, this exact value used only once. That's okay, no problem to use it as constant and just hard coding formula. But if you at least need to reuse your own constant multiply time, it's immediately assumption that it might be fine idea to use absolute reference with place it on somewhere at the worksheet within worksheet or workbook and then refer it multiply time. So direct constant, it's only for single usage. If you want to reuse constant, it is like non-standard constant, because for example, P we have as formulas in Excel, but if it's your own non-standard constant, it's fine idea to use absolute reference. And conventional approach, it's a relative reference, which is point to specific column and row. And it's changed within automatically when you use autofill techniques or copy-paste formulas around the Excel worksheet. So in contrast, absolute reference does not alter it during this operation, at least absolute reference to cell, or alter it in specific way if you, depending, you refer to column or row. I can give an example. I strongly recommend for you to make some experiments on this, because you will have to work a lot with this kind of, with our kind of reference. And such as we will concentrate on statistical calculation, most case you have to use arrays or sample data or even matrix as arguments for function or array formulas. So conventional array delimited by colon, and in reference include start left top cell and end right bottom corner of data range, which contains your data set for array, for sample. It could be linear, vertical, horizontal vector, or it could be square matrix as well. And we can combine array from multiply sets, which we usually separate with semicolon. In this case, one example, you see two arrays, two small arrays combined in set as semicolon. So it would be fine to clearly distinguish set from series of arguments when lots of function required not one but multiply arguments. So arguments are independent objects which is processed independently. Set considered as a single object. Okay. And for those who are students who are like not very familiar with spreadsheet, there is insert function too, which could give for you a good insight about how use specific function. and allow for you interactively choose arguments for it and so on. At the first step, it is necessary just to select necessary or search for suitable function by category or by manual select, and immediately you will be given a short description on purpose of it, whereas in second step, you have the ability to utilize Excel prediction tool, which give for you proposal about possible arguments, or also you can provide valid arguments, because Excel assumption very often working in wrong way. So the only issue with this tool that can be opened recursively from second children instance from parent, and it's very useful, but only for simple function or for editing of part of complex function. If you have a nested function, when function used inside another function, an internal function result of internal function provides arguments for external, that is quite common situation, you will not be able to create such statement in a single run of insert function. That's for me more than enough for speaking about technical skills. If you need more, you can utilize all power of Google search, YouTube videos, and so on, and even materials published in our university Moodle distance education system, which is more than enough to pass through classes. So let's move into our objective of lecture and move more about statistical data analysis, and let's start with statistical calculation. First of all, we need to, but before we will start with some technical implementation, before we will make calculation, it's need to introduce necessary statistical background for you, need to provide necessary statistical background for you, and also we have to get some insight about statistical methods, hypothesis testing, and so on. Because actually, again, to use any software for solving tasks, especially, for example, we talk about spreadsheet and statistical analysis, we have to understand our task and now algorithm for this solution. Then our system software will help us. So, statistics itself is a branch of mathematics which deals with collection, validation, analysis, and interpretation of presentation of data, and medical statistics deals with application of statistical techniques to medicine, health sciences, including epidemiology, public health, forensic medicine, clinical research, and so on. And it's recognized already as a branch of statistical science for decades. Statistics very tightly deal with probability, which is the measure of likelihood that event will occur or does not occur. And it's studied under probability theory, which is actually also independent scientific area. So statistics and probability are related but separate in the discipline, and statistical analysis of news, probability distribution, and two topics are often studied together. And actually we are in touch every time, especially about probability distribution. So chart at the bottom should give for you essential similarity and difference between statistics and probability. So with probability we are given model we want to predict data. So when we toss coins, so what will we get? How many it will be numerical or picture side? And when statistics, we are already given data. We are already given, for example, result of this tossing coins, and we want to expect that it is what kind of is it following some specific pattern, or it's absolutely randomless, etc. So again, when we're speaking about descriptive statistics, we have to identify some items or conceptual objects that we will deal of. Definition of statistics already given, but also as some specific task, we can see statistical techniques as measures of the sample or population characteristics. So here is its importance, sample or population characteristics. Small mistake here in this slide. Whereas population contains our member of group and sample, it's only subset of population. Usually the researcher work with sample and it's have to follow specific rules to create a valid sample from given population to make his research result reliable and useful for assessment. So during experiment, researcher deal with variables and specific characteristics that can form different value from one observation to another. And that's idea of research with registration. It's manipulate one variable and registration results changes in another. And those we can manipulate, it's independent variables that can take on different value which subject to manipulation by research. So researcher depend, for example, observation time, window time interval for make observation, or researcher define like drug medicine dosage which admitted to patient and then perform observation of results by observing response variables that can't be controlled and which only use we measure it and we expect that by our manipulation with a dependent variable our response will be changed. So here is important point to little bit spoken about type of variables and all kind of data that could be observed and registered with our sense or technical capabilities include two large group, categorical and quantitative variables. So categorical are also known as non-numerical variables, could be subdivided in groups like binary, nominal, ordinal. When for binary we have only two possible values like yes, no, and nominal expect more categories like some levels, and ordinal provides that those levels has important orders. That they can't be reordered without losing some details or made a mistake. Here is quantitative variables, which is divided discrete and continuous, and actually represent our numerical measures for discrete cases and uninterrupted values, which is like for natural physical processes and observations. That's last point. I think maybe you get better qualification on physics classes, but I just have to admit that when we perform our observation, any kind of continuous variables turn into discrete. When we observe development of process within time and make some registration within specific point in time, when we register time point and respective dependent variable value, so we turn continuous variable into discrete. So it will be not very big mistake for our classes to spoken about quantitative variables as discrete variables types. But few more details on those categories and categorical and quantitative variables. So with categorical variables or quality, we are spoken about like treatment groups, exposure group, disease status, and so on. And so here is examples for binary variables, which could be or answer yes, no, or also defined as a treatment, medicine or placebo given for students, exposed, not exposed for that epidemiological process, and so on. For nominal and ordinal variables, the only critical point that, that does order may have matter or does not. So both it's like named categories, but ordinal they are ordered. What we have in case of order no matters, it's like material status, blood type, or so on. So that's we can use. Even in this case, might happen that we could use some numerical some digits as labels, but they are considered as not numerical variables. And as for me, very fine example is ordinal variables. And here is we have staging in breast cancer, like which is usually we use Latin numbers. We can use Arabic numbers for this case, but with these numbers, with these digits, we can't perform mathematical operations. So we can't like add the cancer study 1 to cancer study 3. It absolutely does not make sense. So situation when we have numerical assessment, but we can't do any numerical variables. Also, we can't like calculate average. So average between cancer fast study and force give for us so 2.5, what is this? Again, that's does not anything that does not make any sense. Another example which is like extremely, it's students assessment. That's exactly the same things. Or during classes, I offered students their grades like from 1 to 5, or now from 1 to 12 grading system, but they exactly ordinal variables and only represent like hood, but we can't perform some arithmetical operation. So we can, but they are not a lot of make sense there. In contrast, letter assessment and proportion, which reflect about percentage of best students and next to them and so on, or ranking, give for us definitely good way to visualize success of education. Quantitative variables or numerical variables, so we can perform arithmetic manipulation on all these things. It's any kind, time assessment, and so on. So in this case, we have like discrete variables or continuous variables. And here is, if you want to be clearly scientifically correct, so here is exactly what is difference between discrete and continuous variables. Like things, number of new cases of specific illness, so there are AIDS, like not important. We are out into COVID cases within specific country, region, and so on. So here is exactly discrete variables, or years of university completed and so on. Here is when we talk about age or blood pressure, they are definitely continuous variables itself, and then we can register specific points. That's how old are you right now, or which blood pressure you have right now at this specific point when we do measure, when we do observation. So variables itself are continuous, but when we do measure, they are turned into discrete specific value. So and here is, as for me, hard point sometimes to understand. So then when we talk about any kind of descriptive statistical analysis, so first rule, it's again not my rule, I take it from various resources, that we have to use common sense about is it such analysis makes sense, is it such calculation makes sense. And if we are decided to make some manual analysis of our data, so it's fine idea to start visualization charts because that it's very natural for humans to identify any patterns within and retrieve patterns from visual analysis. It's much more comfortable for us. Again, every time, try to think about, does this kind of analysis make sense? Does this calculation make sense? Does this chart make sense? And does it give for us some useful information from data, useful insight? So it's actually very important question to choose a proper chart type to visualize our data. For example, depending to kind of data that we have, like categorical or continuous variables, we will have different choice. Things like column or line chart or bar chart or similar to it, typically useful for categorical variables. In this case, I made emphasis when we have independent variable categorical type. So in this case, dependent variable will be fine to depict in form of bar or linear chart. So it means if we observe, for example, blood pressure for number of persons, it will be like not bad idea to use for few persons, we can use line chart or we can use even a bar chart to visualize this data, because if we deal with different person and we make measure only one time, so in this case, patient will be definitely categorical variable type, and only dependent variable blood pressure, even if it's like numerical and discrete variables, so it's fine. It will be correct way to use line chart. Other hand, for continuous variable, here is I made emphasis mostly when we talk about independent variable with continuous. Of continuous type, so box plot, stem and leaf, histogram, useful as analytical tool, and visualization tool. It's actually the only scatter plot is used. And here is very important notice, it's actually useful, not frequency plot. So we can't use it for made statistical analysis. We can use it only to visualize data, and here is important point. So because here is the sign that we deal with frequency and we are interested about how often specific event occurred or not. And here is we have some insight about what kind of charts do we have. So if we talk about frequency, so here is given solution for categorical and continuous variables, and if we only want to visualize data, so we must use scatter plot for continuous independent variables. In case of no matter if you want frequency plot or visualization data, for categorical independent variable, linear chart is definitely useful. Okay, and here is example of we have categorical variables and want to show frequency of proportion in each category. So here is example, we have like shock indexes, which is shock indexes is definitely categorical variables, and actually also find examples that it's ordinal variables. We have like 10 level of shock index that patient could suffer, and orders here is have matter, so it's ordinal variable. And here is we have assessment about how many patient claimants that they suffered of this kind of shock index. So in this case, we have bar chart, which is also play a role of frequency distribution for our data set. More about distribution, I will spoken about second part of this lecture when we'll spoken on hypothesis testing. And another approach for continuous data, it's usage of stem and leaf plot when we separate sorted data series into leading digit and trailing digits. Actually useful mostly for a relatively small data set, but provide good insight and good and quick insight for our data set. And here is example we have for like one variable, or even if we have two dependent variable with the same independent, like age. So we want to compare age for male and female in some specific investigation. And the histogram, also very conventional chart type in case of continuous variable. When we measure some, when we have, we measure, we register of occurrences some event, for example, by using time. So, for example, when we have, in this case, arrival per minute, and we have some schedule of arrivals, for example, at airport, or when we make registration of patient arrivals in emergency department of hospital. So, for example, during this pandemic, when we want make assume frequency, how often patient arrives per minute, for example, or per hour, it's no matter how we will spread this our intervals. So we just turn this data into frequency distribution or a histogram. And here is important to say that in this case, input value is has to be something like timestamp, time points. Then we just register that this specific event happens in this point, if you want to make this registration. And actually very useful to provide rogue assessment of probability distribution for continuous variables. Again, more about this some later. And it's time now to define what is descriptive statistics itself. When we already spoken, when already provide some insight about how to visualize our data, it's time to define what's finally is this. Such as we have our data set samples of population data could have very different features. So descriptive statistics, it's give for us quantitative describe optimization features from collection of our data. And also we can see descriptive statistics as process of retrieving and using those statistical assessments within our scientific analysis. And it's have to be distinguished from inferential statistics by its aim to summarize sample. Rather, they use data to learn its population had the sample of data it's talk to represent. But also we have to understand that usually before we will be able to start with inferential statistical analysis, for example, it's a good example, it will be spoken today. Hypothesis testing, it's kind of inferential statistics. We must collect descriptive statistic assessment. So it's actually essential part of inferential statistical analysis. It's retrieving descriptive statistics, and based on this, we have start our analysis, our data analysis. Okay, so summarize on this, descriptive statistics, that summary statistics is quantitatively described and summarized features from collection of data. Actually, use term data, it's even more correct than information there in this case, because actually descriptive statistics give us information from our sample data. And we have 4 general groups of descriptive statistic parameters where pair is like major, and we have some auxiliary. So pair of major descriptive statistic measures is central tendency and variability, and auxiliary it's quartiles and shape assessment. And here is even not all possible descriptive statistic features presented, and just most commonly used, like arithmetic mean, median, mode, geometric mean for central tendency, and number of variability characteristics like range, the quartile range, variance, standard deviation, coefficient of variation for variability. Okay. And again, those assessments more or less related have to be usage of those assessments again depend to our data type, depending if we have interval level data, nominal ordinal data. So for non-interval level or discrete data, measures of central tendency and variation common descriptive statistics, and like central tendency give for a single value assessment for our data sample, and variation describe how widely data elements vary from given central tendency, and some standardized scores combined both central tendency and variation into single description comparable across different samples with samples or different units measures. It's typically used. And a fine example of standardized score, it's how we represent, for example, mean with addition of plus minus of mean error. It's example of standardized score. Or standard deviation plus minus interquartile range, and so on. Okay, so. And phenomenal ordinal data proportion are common methods used to describe frequency as they compare to a total. So which percentage of patient has that best grade? Okay, technically it's not difficult to calculate most of descriptive statistic parameters, but sometimes it takes time. So here is we have some of this could be just selected from given data set, and some have to be, most have to be calculated, like mean or geometric mean, and other. And here is like how do they look like in specific data set when we have given example of age variable and few observation for various person. So for given independent variable age, when we made some and we collect data only about age, which will be X in this time, we are given number of scores, so our experiments contain only 7 assessments, and we can give here mean, and so median is at most midpoint of our observation, and mode that's most occurred case when we have like 2 persons with the same age, full number of years, so that will be exactly mode of our sample data. So why do we need a few central tendency assessment? In fact, it's because some of those descriptive statistic, or in this case central tendency assessment, could be affected by outliers or extremely low or extremely high value, or which could be even like added to dataset by mistake, but not in our case. So we don't know whether it's outliers, it's features of this distribution, sample, or it's like caused by mistaken observation. But when we compare those central tendency assessment, we can make some assumptions, some suggestion on this. And here is example how easy, for example, mean could be affected by outliers. We have 2 samples with the same size, but only one have one value which is significantly different than other. So mean immediately changes. In contrast to it, median does not change, and midpoint of data set remain in the same place. So only given these 2 assessments for our sample, we can make some conclusion about symmetry of it, about presence of possible outliers, and so on. Even if I don't have my sample data. And I will now only mean and median, so I can make some specific conclusion. Now move into variability. So measures of variation give information about spread of variability of data variables. And here is a picture given fine example when we have two data set, like continuous data set definitely, with exactly the same center tendency. So they will have exactly the same value for mode, median, and mean, but due to variability, they are significantly different. So, and it's why studying of variability is very important, and presenting variability also very important. And fast assessment of variability, it's very often start with definition of quartiles, which represent 4 quartiles of our data, and we split 1 quarter, 25% of our data between 4 different quartiles, and so on. And then starting from idea of quartiles, we deal with range, which is different between maximum and minimum, largest and smallest observation value in our data. And it could be compared to interquartile range, which is different between obviously third and first quartile, where median represent exact second quarter value. And again, assessment of range, interquartile range, give for us information about possible presence of outliers and so on. Other descriptive variance assessments, like variance, which is average of square deviation between individual scores and means, and largest variance, more variability there is among the space, and standard deviation, which is square root of variance, provide representation of variation among scores that is directly comparable to the scores. And so here is we have formulas, and it's a given approach how to make those as calculation manually or semi-manually, and it's actually not very difficult, but take time. So here is reason why it's a very conventional question now to replace descriptive statistical calculation with any technical solution, for example, by using spreadsheet. And also important point to get insight to why do we need various various variability assessments. So now another example with 3 different data sets, which have again exactly the same mean and exactly the same central tendency. So I will calculate in addition mode, median. Again, they will be exactly the same. And here is like practically with discrete data, how it could be look like. And again, if you will be provided with standard deviation for this case, so we can spoken about how data distributed far from the center of our data set with value of standard deviation. And let's get back at this point to visualization. After you get some essential overview of descriptive statistics, what is this? So it's time to introduce you with box plot or box and whisker plot, which is a special type of statistical chart and which used to depict descriptive statistic characteristics of sample population data set, and very often placed with most of the scientific paper which include statistical analysis. So here is we have on one chart characteristic of whole data set. Most of major descriptive statistic characteristics. So are given displayed maximum and minimum, given expected maximum and minimum as whisker with this horizontal crossing bar. So all measured value which does not fit expected expected force or quartile could be seen as outliers or behind the fast quartile. And we have central box which limited with interquartile range and has median at the center. And alternative, it's use mean and the mean error as borders for box plot. So we have variation of box plot depending what is will be shown as central point, median or mean. Okay. And one more notice at this point, such as when we will deal with statistical analysis and statistical textbooks, have to understand that most time you will not using term variance, standard deviation, population variance or standard deviation. It will be replaced with specific characters like S, sigma, mu, and IQR and other abbreviation. And now I will switch for a few minutes to spreadsheet application and will show for you what we can do and how we can make some descriptive statistic analysis with spreadsheet. And here is we have common calculation and visualization. Let's move into our spreadsheet. So here is I have a few like numerical data set which is like composed actually the same number, but depending what I have denoted like independent variable. In this case, patient, we made some observation from patient, no matter what kind of data we obtain, there are some kind of good parameters or so. But here is we have independent variable nominal and dependent variable is discrete. In second example, I replace patient as independent with time point, like first, second, and so on. So during each 1 second, I make some measures from two patients. So in this case, we have definitely this continuous independent variable, which turns into discrete. And in this case, definitely my dependent variable will be also discrete data type. So here is we have nominal, probably independent variable, and here is we have example how it will be look like for discrete variables. In case of visualization, in this case, it's no problem to insert like linear. The correct way will be to select only dependent variable and visualize it with chart. Or definitely it's possible to use, if you want to get some descriptive statistic assessment, still possible to use a histogram. In this case, we will know how much patient, what proportion of patient get that vital parameters within specific range. So we can make histogram for dependent variable in this case because it's definitely discrete. But if you want to compare it, so line chart is useful. In case of discrete or continuous independent variables, so the only correct way for visualization is to use scatter, which is in origin give for us exact point and relation between x and y, or if we assume that it might be by a signal or something similar, we can use segmented line or a covered line, or we can even compare and make some visual correlational analysis in this case for our data set. This does not, it makes sense. Similar way, technically, we can calculate histogram, you can draw histogram for this case, but here is we have to think a lot of time, does that make sense, because we measure some things during time and it might be periodical signal. In this case, that it makes sense to calculate, to visualize it with histogram and get frequency distribution for it. Technically, it's give it will be given, but it does not make sense at all. And for discrete dependent variable, we have ability to calculate technically every time we can calculate box plot, and we will have let me check. We can add the like data labels, and it will be our descriptive statistic parameters in case if you want to do it in visual way. Or same way we can do it for two groups at a time. And it will be something like this one. Here is we will have data labels, and we can provide some comparative analysis for our sample in this case. Technically, we can do exactly the same things for in case if we have continuous independent variable. Again, the question only, does it make sense? Does it make sense in this case? Because we have to be aware that it's not like periodical signal. Okay, and one more example. It's calculation of descriptive statistics. So here is a visual approach to calculate descriptive statistic with box plot chart, and we can get it in numerical form by using data analysis. It's like subset from previous sample. Just question to get it technical, and for sure we do it only for dependent variable. Our independent expected to be categorical in this case. So I want to go some summary statistics, and I want to place it at exactly the same worksheet. So here is example, how do I get all this assessment? And just to compare again, I will insert one more example of box plot at this place. So if you will compare, you will see that it's here is we have maximum, minimum outliers show for us, and we have our interquartile range, we have a median, which will exactly fit our numerical data set. Here it is. Okay, so what I want to admit at this point, it's extremely easy to make those calculations with a spreadsheet. So question is only, does it make sense? And what kind of information we will obtain from there. Let's continue. Let's continue and move into hypothesis testing. And here is point to define what is distribution, frequency distribution, and so on. Distribution of statistical data set is listed over functions that show all possible value intervals of data and how often they occur. In this case, we assume that our independent variables is discrete or continuous. And frequency distribution is grouping data in multiple categories showing number of observations in each class. So here is we have like given, we split our observation into range, and we give how often cases get into the specific range. And numerous sampling distribution used in hypothesis testing, its most common is normal distribution. How data would appear if we create frequency histogram where x-axis represent value of scores in distribution and y-axis represent frequency of scores. And here is again, we assume that's our x variable, or what we place in case of x variables, has a continuous or discrete type. So, and most scores will be similar, therefore I will group near the center distribution. Some scores will have unusual values, will be located from far center from distribution. So properties of normal distribution form symmetrical bell-shaped curve. They lie 50% scores lie below and above midpoint. They are asymptotic to the x-axis, mixed median mode located at the midpoint. And we have three sigma rules for standard deviation when between, so no matter what population of Mean of population and standard deviation of population are, but 68% of observation will lie within one standard deviation from midpoint, 95 within two, within double range of standard deviation from midpoint, and almost everything will be lie within three sigma, three standard deviation from midpoint. So here is how it's look like. That 1, 2 sigma and 3 sigma rules. How do they work? So again, we are speaking about continuous variables of continuous nature. In reality, it's almost never happen, and every time we have right or left skewed and other distribution type, which is deformatted by height or so. And actually, we use like skewness kurtosis measures in statistics to make the assumption about does this deviation from either our critical and our data sets no longer normal distribution or not. And actually, again, I back to this histogram to sign again that's why that could be used for rogue assessment of probability distribution. So we can apply the normal distribution curve and we can make decision about is it we have our data normally distributed or not. And if we compare it to previous chart, it's definitely true that we have a right skewed distribution in this case, which is a little bit similar to normal, but right skewed. Okay, so hypothesis testing. Hypothesis testing is a form of statistical inference analysis that uses data from sample to draw a conclusion about population parameter or population probability distribution. So we explore our sample data and try to figure out that is it our conclusion will be true for whole population. More widely, hypothesis testing is acts in statistical variables and list test assumption regarding population parameter and methodology employed now depends on nature of data used for reason for the analysis. And it has to be used again, possibility of hypothesis by using sample data. So again, we have made emphasis on reason for analysis and nature of data, because technically, again, with data, equation, like spreadsheet tool or any other computer software to calculation, we can obtain a result. Does question will remain, does this result make sense? Okay, so like steps or main chains for reasoning for inferential statistics. We assume that population normally distributed and samples must be randomly selected, and sample estimate is compared to underlying distribution of the sample size sample distribution, and with the mind probabilities that sample estimate reflect population parameter. And data characteristics must match statistical techniques. For example, for interval ratio data, we typically use so-called parametric statistics like test statistics or student statistics, Pearson correlation, ANOVA regression, and regressional analysis. When in case of nominal ordinal data, difference of proportion, chi-square, and related measure of association has to be used. Okay, like rogue algorithm about hypothesis testing, including analysis, overview of data, and decision about statistical general model. Then statement, null and alternative hypothesis. It's very important point when a lot of students made mistakes. They immediately try to provide conclusion and make decisions that's which one of these hypotheses is true, but it's definitely incorrect way. At this stage, we can only make two concurrent statements, two concurrent assumptions about possible outcome. Then, again, we have to look in the data and decide about appropriate statistical test, depending to nature of it, depending to distribution type, calculate it, and depending of what do we have, like our significance, how to relate it with our confidence level, and what kind of descriptive, statistical value compared to critical value, which is obtained from separate calculation or special statistical textbooks, we can make decision about accepting or rejecting null hypothesis. Usually we follow this pattern, like when calculation less than critical, we accept, calculation greater than critical, reject null, but actually it's not in all cases correct, and we have to study again statistical manual for the specific test which had been chosen in order to clarify yourself, is it how we made decision. In opposite case, when our significance don't match or exceed critical value, we are failed to reject null hypothesis. So in this case, it does not mean that we have to like accept alternative or so. No, it just means that there is no evidence that we have ability to make correct decision. And unfortunately, it happens in science quite often. Okay, question again, that third step of previous algorithm. So how do we decide about exact statistical test? Again, it's part only of algorithm because it does not cover all possible statement. But we still rely about what kind of data we have, categorical or continuous. For categorical, we have to compare proportion in groups. And in case of two more groups, we must use chi-square test. For continuous variables, depending to, we have two groups or more than two groups. And depending to does we have normal or abnormal distribution, we must use for two groups and normal distribution test statistics, Wilson test for non-normal distribution, then analysis variances for analysis of variances for three groups, within normal data, and the Kruskal-Willis test for non-normal data. So actually, even it's not complete list of available tests. And actually, the following slide give for us more, but for only 4 general practical classes. When you will study materials, practical class materials, you will see extended version of this table, which include 6 classes of practical tasks. And even those not cover all possible cases and used mostly for educational purposes and to give for you essential idea how to make this choice. So still, how do we have to use this table? Have to follow it from left to right side. And at first stage, that exact first stage we've spoken about, look into data and about decide about general statistical model. Depending, is it we have control experimental sample, or is it we have sample data before and after experiment. So if we have like 2 groups and one given medicine and placebo, it's definitely control experimental groups. And when we make observation for students, for patients before and after they taken this particular medicine, so it will be sample data before and after experiment. And here is we have to decide about, so then second column give for a statistical model like independent sample mean comparison for first case, or dependent sample mean analysis for second case. And if you want, for example, decide after patient taking medicine that their vital parameters reach specific given level, we get into third case, comparing sample mean to constant, and here it will be one more statistical model, and so on. With given statistical model, we have to make statement for hypothesis like null and alternative with pattern which I provide next slide, but usually it sounds like there is no difference in statistical parameters. Independent sample mean, dependent sample mean, independent sample variances, and so on. An alternative which spoken about, so there is present significant difference between compared statistical parameters. And here is at this point, it's critical, it's crucial point when the researcher have to explain reason what will be practical outcome for this, because at this point it's time to get for you emphasis about major benefits as well as major weakness of statistics. So they are deal only with descriptive statistic based on the usage of descriptive statistic sample observation assessment, and they are absolutely abstract value. So they does not have real connection to reality. As a result, from there come benefits of statistics. We can use statistical techniques within various application, not only in medicine, we can use it in engineering, we can use it in social studies, and so on. But in this case, it's a health weakness point of statistics. So only researcher responsible to correct explanation. Okay, we have or does not have this equivalence on statistical parameters. So what is practical outcome for this? So if it doesn't have difference in sample mean, doesn't have that we have difference between medicine, new medicine and placebo? Probably not. And like if taking medicine don't change specific parameters, does it indicate that medicine is effectiveness? That's in fact only indicates that this medicine does not affect these vital parameters, but it could affect one another. And here is it to be carefully tested, all possible outcome. So third step will be to make assessment, is it distribution of our sample observation data set normal or abnormal, and depending to it we must come into single cell which will depict the only correct method which could be applicable for hypothesis testing in this specific case. So as you can see, we have a lot of points to make mistake, and here is actually happens too often in the real scientific investigation. Again, I made emphasis. This order is extremely important because last column every time represented by various formula. With formula and data and spreadsheet, every time we can obtain results of calculation. But if chain of assumption, chain of suggestion and decision which led to choice of specific method for hypothesis testing were wrong, your result will be useless. And here is difficult point maybe sometimes to understand. When we can do everything technically correct and got result of calculation which is technically correct and which does not means nothing. So statement of hypothesis, I already provide some introduction. We provide no hypothesis, like mostly sound, no difference between given statistical parameters, and we have to explain what is practically means in term of our task. Alternative, spoken about presence of significant difference between a given given sample population parameters. Here is we have sample mean usage depict, and we have to be able to explain practically what does it mean. And it's important to choose rejection of criteria or alpha level or critical value, which is can't be more than 5% for medical research. And it's determined how different parameters and non-statistic must be before no hypothesis can be rejected. So it's like threshold that we told about our evidence are enough, and or our evidence too weak. Definitely you have to understand 5% of error means in case of 100%, 95 taking drug will got positive result, but 5 will not, for example. And it could be dangerous for them, and so on. So in case how we could be practically used alpha level for left tailed hypothesis testing, we assume that equivalence null hypothesis in like population mean, and here is we expect difference population mean for alternative hypothesis, and our experimental must be less than a control. And here is we provide area when we have to, our calculation will fall in reject area, so we have to reject null hypothesis like it's false. In case of two-tailed test, we have to split alpha level by 2 diapason, and we test hypothesis like in case of equal does not equal null spoken, that's parameters are equal, and alternative they are does not equal. And here is how we can make this, how we can determine alpha level in this case. And all three possible cases, two-tailed, left and right-tailed test here is shown there, and a correspondent statement of hypothesis given there. Why I am made point on this? Because usually it's not enough to make single test for hypothesis testing. Usually we first of all start with two-tailed test just to provide evidence that yes, like new treatment or new medicine gives some effect, and then we have to evaluate does it's positive or negative, so how it's change average in our population, decrease or increase depending to what is interesting for us. So then we have to perform one-tailed test after that. And if we reject null hypothesis, we conclude that it's enough evidence to infer that alternative hypothesis true. But if we fail reject null hypothesis, we conclude that there is no enough statistical evidence to infer that the alternative is true. But it does not mean that we have proven that null hypothesis is true, because it still have chance for type 1 or type 2 error, and it could be very dependent to problem. So actually we can depict it with very simple charts. So on type 1 error or alpha error occurs when we reject true null hypothesis. And here is place of when it's happened, when we have null hypothesis is true and correct. It will be that gray square correct outcome, but we decide that we have to reject it in some circumstances, in some reason. And same type 2 error, better also correct. We don't reject false null hypothesis, so don't reject null when it's false. And here is again correct outcome, but place of type 2 error it's happened. That can be seen one reason very easy, like what is this? When we decide null hypothesis person pregnant and alternative person not pregnant, it could be depend in some funny way, but reality not so funny. And in reality, when we deal only with a numerical data set, it's very difficult sometimes to identify situation when we fall into one of this error. So we can reject null hypothesis with its when it's true with published premises like in movement really different, then new treatments really better than all, and it's could be wrong because we have some mistake in our analysis, we have incorrectly formulated samples and so on. So it's exactly type 1 error. And type 2 error make mistakes. There is no significant difference when it's really present difference. Difference could be, for example, it could be a situation when it's too small, it does not matter much and very hard to detect. The difference is big enough, but sample size was too small to tell us so much. And we have more number of reasons for type 2 errors. Okay, and few words about significance. Which actually we have when we conduct a statistical test with some software which exact probability of type error is calculated, and it's presented in most commonly reported as significance. So here is that exact things. When you obtain significance, it will be your probability of type 1 error. But type 2 errors, there is no such kind of measures which could be immediately obtained. From some reason, it could be 1 minus significance, but it's not every time yet proper to do this. And here is we have like situation about, so what is probability of made type 1 error, and if we have it's less than 5%, our result is statistically significant. But if we have greater than 5%, like in second and fourth row, so our evidences are too weak to make conclusions that we are true. And here is example of how we can depict it visually. When our significance closely to 0, we talk about our having evidence, but also we have to be aware that it could be some bad indicator of that's our data to very like fitted for our results, about our fitting. And if our result we have greater than 5%, we have weak evidence for to be success, and almost no evidence over 10%. Okay, so it's like a minimal required theory, and here is what is like technical tool could help us. As it's obvious from previous, all hypothesis testing methods represented sort of formulas in statistical textbooks. So we can do it with function and manual calculation by formulas in spreadsheet definitely. Also, we have, I'm not speaking right now about specific software which is dedicated for statistical analysis. It's even more easy there. But also we can use automation tool like analysis toolpack or other which is few available. So here is on how to enable analysis toolpack in your spreadsheet, and we have a number of descriptive analysis tool for performing various type of statistical analysis there, which include descriptive statistics, hypothesis testing, correlational analysis, etc. And regarding hypothesis testing, we have Fisher test, test statistics, Z-test. As you can see, all this related to parametrical assessment. In case of non-parametrical assessment, so only formulas and formulas usage, it's eligible. Okay, and here is example how we can start analysis and how we can fill dialogues with from our sample data. In case if you want to make calculation of test statistic, Fisher test, as you can see, both dialog quite similar. We need to provide only range for our two variables. So with hypothesis testing, we deal every time. With parametrical assessment, we deal with two variables only. If we want to 3 or more, as I see, analysis of variance and other methods is useful. And here is only question where is provide alpha level and output range. So all things as take care of spreadsheet, except one point's order of samples. Excel does not make this test. For example, if for Fisher test order of variables is important, you have to first of all calculate variances itself, decide where is greatest, and provide variables in this order. For test statistics, in contrast, we are looking difference in mean, and it's not such critical to have correct order. You will just fall into negative value for test statistics. But to avoid this, first variable has to be those which has greatest mean. So that things has to be pre-calculated with descriptive statistic before. And it's actually one reason to get descriptive statistic one more. And here is we have outcome for Fisher test and test statistics. And it's exact point when Fisher test from one side, first statistic less than critical, spoken about equal variances, but significance level spoken about 44% of type 1 error. It is absolutely no evidence that we can accept this hypothesis. And then when we start test statistics, in contrast, we have test statistics like if we consider two-tailed or even one-tailed, both case test statistics greater than t-critical, no matter one-tailed and two-tailed, and significance in this case quite low, significantly less than even 1%. So we have more than enough evidence to reject null hypothesis and make decisions that there is present statistically significant difference between these variables. And in this, according to task, we are looking for difference in blood parameters in persons. So if we would formulate null hypothesis like no statistical significant difference and blood parameters not depend to gender, so alternative sounds like there is present significant difference and blood parameters depend to gender. And here we have definitely comparing control experimental sample, and I already skip a normal distribution test, which is only could be given by assessing of skewness kurtosis in this way. And probably they are normal because it's quite low value and they are fall into limitation of normal distribution for this parameter. So test statistics, which is definitely correct way, but we have to be, it's had to be prepended by Fisher test. And Fisher test provide unreliable result. So still we made attempt to make test statistic for equal variance, or we can proceed second test with non-equal variance approach. But given this point, our test statistics less greater than t-critical, significance less than 5%, so difference in means is statistically significant, and we can reject null hypothesis for our alternatives that blood parameters strictly depend to gender. And within the last few minutes, I will try to repeat this analysis with my data when I have like unknown vital parameters. I made assessment, no matter what is this concentration of like some medicine in blood or so, okay, or some level of some blood assessment parameters at taking medicine or placebo. Okay, let's start first of all. No, we already have descriptive statistic. It's question only to make decision about skewness kurtosis. Is it about distribution type normal or abnormal? And I want to assume that from my experience, only this kurtosis value indicate potential deviation from normal distribution. All other three value quite low, and but to get exact correctly answer, we have to follow strict statistical rule, and you must obtain critical value, that is critical point. Anyway, we can proceed with parametrical methodologies for making hypothesis testing. Here is obvious, such as we have two groups of patients that we compare control experimental sample, and we are looking for difference in mean for independent sample mean. Null hypothesis spoken that there is no difference in mean, alternative there is present difference in mean. Practical explanation left behind the stand because I even don't know what exact vital parameters I'm working with. In this case, I must pass through Fisher test again, because I already proved that we have minimal deviation from normal distribution. And so for Fisher test, I have to use variable 1 for this range which has greatest sample variance, and it's group B. So my variable 1, it must be group B. And my variable 2 range, it's group A. Because of sample variances, I selected with labels, and my output range has to be somewhere here at the bottom. Okay, so here is I have Fisher statistics about variance, and it's spoken for me that like Fisher test, we have smaller than critical, so we have accept conclusions that variances are statistically equal, but they does not provide answer about sample mean. We are speaking right now only on variance, but probability of type 1 error, it's too large, almost at 24%. So we can accept null hypothesis. We does not have enough evidence to accept of null hypothesis. Okay, we can try continue analysis with assumptions that variances are equal, or we can do it for unequal variance. Let's assume, okay, for unequal variance fast test statistics, this case would be better to provide order where mean greater as fast variable. In this case, it will be group A. So I follow group A, it's a fast variable, group B, second variable. Again, label I have, output range will be started from this point. Okay, and just to compare, I will give for you also value for test statistic for unequal for equal variance, just to compare how our what kind of mistake we will have for equal variance. Again, we have provided the same input, group A, group B. Labels, and usually it's not quite a good way if we will use all possible tests, but in this case, as you can see, test statistics for equal unequal variance provide for us almost exactly the same result. We have test statistics don't change it. We have only minimal changes in the critical to tailored, so and actually difference in degree of freedom we have here, because the methods are different, so why it's important to understand. Anyway, both cases we have a situation like our test statistics is bit greater than the critical to tailored or the critical one tailored, depending what kind of test we perform. I assume to tailored. And our evidence also, significance also very good, because it's lie about, we have probability of type 1 error about 2.5%. So but we have a good evidence, strong evidence that our statement will be correct, and we can reject null hypothesis in favor of the alternative, which we've spoken that there is present significant difference between sample means. And again, that's only the main question for us to explain practical outcome. Okay, we provide proof that there is present statistically significant difference between mean and independent samples. What does it mean practically for us? That's all I have time for you to present today. Thank you for your attention. And we will continue on this lecture next time.